Welcome to part 2 of my Blender tutorial on material shading. If you stumbled across this video first, there is a part 1 that covers the absolute basics of shading in Blender. Part 2 is all about PBR materials, what they are, where you get them, and how to set them up, with a bunch of extra tips along the way and at the end. I will be using cycles for this tutorial. Most of this will work in EV2, so let's go. The PBR in PBR materials stands for physically based rendering. It's a workflow for using physical information, images, to generate textures. You could make your own PBR textures, but don't, because there are tons of them already out there. PBR textures are generally going to look much more realistic than procedural textures, which are made by combining inputs like we did in part 1. When you obtain a PBR texture, you're going to get a series of images with specific labels. Each image controls a different effect of the material. So where do you get PBR materials? Lots of places. I often use Polygon, which has both free and paid materials. I've been happy with them and will include an affiliate link in the description. But there are other places to get free PBR materials for Blender. Ambient CG is one place I would check out, but I'm going to be using Polygon. You can see they have a pretty large library of really good materials. When you choose a PBR material, also referred to as a PBR texture, you have different resolution options. For example, here we have from 1K all the way up to 16K. Polygon uses PNG images, but some sites have JPEGs, which are smaller files but can be lower quality. Which size you choose will generally be based on how far away the material is going to be in your scene. For things in the background, and honestly for most of your scene, 1K is probably fine. If it's going to be close up to the camera, consider going up a size or two. Generally, I find 3K to be fine for almost anything. The larger the resolution, the more it adds to memory draw and render times. These are all the different maps the texture comes with. I know I won't use them all. In fact, the 2 bump maps and 2 displacement maps are just different size options you can use with this material. But they don't cost anything extra, so I'll just download them all. They'll all download into a zip file, which of course you can unzip on your computer. It's generally a good idea to store all of your PBR textures in an organized file system. You can change the names of the folders, but don't rename the actual images themselves. They're named the way they are so that they can be recognized by certain add-ons, which we will see later. Let's go back into Blender and just start with a new plane with a new material. I'll name it Polygon. Then let's go into the shader editor. We've got our default principled BSDF shader. I also have the file folder open with the files I downloaded from polygon.com. We can bring these files into the shader editor a number of ways. We could press Shift-A and add an image texture. This is the node that plugs images into your node tree. We can press Open and navigate to the folder where the material files are. Or if we have the folder open, we can simply drag and drop an image into the shader editor. Blender will automatically add it into an image texture node. A side note, you can navigate to and open these image files even if they're not extracted, but dragging and dropping the files won't work unless you extract the zip file. That's good to know. The first file we are going to start with is the one labeled color. Actually, there are different variations provided with this material. These are just slightly different color options you have with this material. I'll pick one and I'll drag it into Blender. Since this is our base color, we are going to drag the color output, the yellow, into the base color input of the principled shader, which is also yellow. Now we've got our PBR base color laid out. If you've made it this far, please hit that like button. It would mean the world to me. Thank you so much. Next, we're going to work on our specular input. Remember in part 1, I said there are 2 workflows, specular and metallic. Let me just go back to Polygon for a second. For certain metal materials, you'll see an option for workflow. You can choose metalness or specular. These are the 2 workflows I mentioned in part 1. There are different reasons to use each one. It seems metalness is more popular for metal materials. Either one you want to use is fine. It'll just change one map that you have to plug in. But for materials that are not metal, you won't see a metalness map, and you'll use a specular map. But notice we don't have an image labeled specular here either. Sometimes specular maps are called reflection maps. We do have a map labeled reflection, and that's the one we're going to use right here. Drag the reflection map into Blender and connect it to the specular socket. Reflection equals specular. Now we have an issue here. We just plugged a yellow socket into a gray socket. This isn't the end of the world, but when using an image texture, but not using it for color data, we need to change this drop-down box from sRGB, which means color, to non-color. This tells Blender that even though this is a yellow output, it's not putting out color information with this particular map. The end result will usually be just a little off if you don't change this setting for non-color maps. There's one step we missed here though, and that is the mapping we covered in part 1. We want to make sure these image maps are being mapped properly to the object. We need to add both a mapping node and a texture coordinate node. Luckily, since we have the Node Wrangler add-on activated, there's a shortcut. Select one of the image textures and press Ctrl T, and it automatically adds both nodes. And it told the texture coordinate node to use the UV mapping, which is what we want. I will very quickly explain UVs. When we take a two-dimensional texture and place it on a three-dimensional object, we need to essentially unwrap the object. Imagine printing a label directly onto a cylindrical soda can. UV unwrapping would be like cutting the soda can open to lay it out flat so that a printer can print on it. The U and the V represent the two axes of the two-dimensional texture because the 3D object already has the X, Y, and Z axes labeled. Unwrapping a plane is pretty much unnecessary, but it's absolutely necessary for more complex objects. To unwrap an object, we go into edit mode, select what we want to unwrap. You can unwrap different parts separately. Go to UV at the top, and there are actually different ways to unwrap an object. Usually I recommend Smart UV Project. Select that, it has some options. Normally you don't have to change anything. Press OK. We don't actually need to do this here, but if you wanted to edit your UV map, you can go to the UV editing workspace. This is our UV. It's a very simple UV, but a UV nonetheless. There are plenty of Blender tutorials for UV unwrapping. This was just the bare minimum to understand. So let's go back to our shader editor. So this color image is mapped through the mapping node, and this specular map is not. We want to connect this mapping node to the specular map as well. Remember, an output can go to multiple inputs, but only one output can go into a single input socket. Back to our material files. The next thing we want to map is our roughness. But again, there is no map labeled roughness. It's because other softwares use gloss maps instead of roughness. So you don't always get a roughness map, but it's okay. I'll show you how to work with the gloss map. Let's drag the gloss map into the shader editor. We will again change sRGB to non-color because this isn't providing color information to the principled shader. It's providing black and white data. And we'll also connect it to the mapping node. All of the image textures we use will get plugged into this same mapping node because we need them all to line up with one another. Now, when we connect this gloss map to the roughness socket, we see a noticeable difference in the material. That is, if we're in render preview mode. A roughness map will make a material look more realistic, but there's a problem because the gloss map is actually the inverse of a roughness map. What's black on a gloss map is white on a roughness map, and vice versa. So the parts that are supposed to be rough are not rough, and the parts that are not supposed to be rough are rough. To fix this, there's a handy node we can add between the gloss map and the roughness input that flips this all around. It's called an invert node. Shift A and search for invert. Drop this right between the two nodes. This node takes data in from the left, like all nodes do. It flips or inverts the black and white values. Then it spits out the new information on the right. There's another map in this pack that will add a lot of realism, and that's the normal map. Normal maps, as mentioned in part 1, fake depth by manipulating how light hits the material. They are not very draining on your computer, but add enough realism to be used as long as they're not right up in front of the camera. The normal map is this purple map. It's a specific type of color mapping that I don't fully understand, but that Blender does. So let's drop the normal map into the shader editor. We again need to connect this to our mapping node, and we again need to change it to non-color data. This normal map needs to be plugged into the normal input of the principled shader. But look, we have a different problem here. We have a yellow going into a purple, and that's a no-no. So what we drop between these nodes is a normal map node. Shift A and search for normal map. This node takes yellow socket color information and turns it into a purple output specifically for normal maps. This is the strength of the normal map. Let's click on it and change it to 10 to really emphasize what this normal map is doing. Boom. Did you see that? How much realism the normal map added when we turn the strength up? This is one area where these materials work a lot better in Cycles than they do in Eevee. If we turn this strength up in Eevee, it really won't do anything. Cycles is just much more capable of handling details like this. A quick break because YouTube pays me practically nothing for these videos. Topaz Studio is one of my favorite tools to use after I render in Blender. It's a collection of very powerful filters. I use it on every single render. Here's an example of a render straight out of Blender, and here's what it looked like after using Topaz Studio. I am not sponsored, but I made an entire video on Topaz Studio and have an affiliate link in the description. There are endless adjustments you can make to improve your render, and the best part, it's a one-time purchase with no ongoing subscription. Please support my channel by checking it out with the affiliate link in the description. Thank you so much. Displacement maps in Blender give you another level of realism. I'm going to turn down the normal value to demonstrate this. We can drag the displacement map into the scene, change it to non-color data because it's not going into a color socket. We also want to map this to our UV by connecting it to the mapping node. Now, this map is going to run into the displacement channel, not the surface channels like the others. If we drag it directly into the displacement channel, it's not going to work because we have a yellow going into a purple. Similar to the normal map, we need a specific converter to change the information from this grayscale image into the information Blender needs to make this displacement work. This time, we are going to use a displacement node and drop it between the displacement map and the final output shader. But this automatically plugs the input into the normal socket. We actually want this image with black and white color information to affect the height of the displacement, not the normal, because it isn't a normal map. To actually see the changes for this, we need to be in render preview mode. They won't show up in material preview. When we plug the displacement into the socket, a couple things happen. We do see more detail in the bump of the material. Also, you might have noticed the entire object kind of shifted. This shifting is because of this mid-level setting. It offsets the entire geometry, and most of the time I found I don't want it to do that, so I changed this to 0. Okay, this added a little bit of bump, but what's the big deal? Well, to really show you the power of displacement, I'm going to duplicate this plane. Let's go to the material panel and scroll down until we see the settings tab. Open settings, and under surface we find a setting for displacement. This setting tells Blender how to use this displacement map, either as a true displacement map or something called a bump map, which is similar to a normal map as far as the end result. There's also an option to use both bump and displacement, which is going to give you the most realistic effect probably. What it defaults to is the bump map, which is what we see here. A little more detail without any more geometry needed. Let's change to displacement. Nothing really happens. This is because true displacement uses the geometry of the mesh, and this plane only has one face on it. Let's select this plane, tab into edit mode, and subdivide the plane a few times. Now, when we tab into object mode, we see the displacement has done something, but this is not right. On the displacement node, the scale setting affects how strong the displacement is, and the default of 1 is just way too high. Changing it to 0.1 is probably more appropriate. But it's still not great because we only have so much geometry here. Adding a subdivision surface modifier will help. And we should change it from Catmull to simple because we don't need the smoothing effect that the Catmull provides, just the geometry. This is all right. There are a couple ways to make it better. We could use more subdivisions or a higher resolution displacement map. But realize that now we are significantly impacting the performance. We've added a ton of geometry to this plane already. The absolute best way to do this is actually to use adaptive subdivision. And I fear that this section of the tutorial is already dragging on way too long. But adaptive subdivision is intelligent subdivision that subdivides the mesh more the closer it is to the camera, and it's perfect for this. To use it, you have to be in cycles, you have to turn on experimental in the render settings, and then on your subdivision surface, you'll have an option for adaptive subdivision. Check that, and you're going to have this displacement be about as realistic as you can get it. For a lot of things, normal maps and bump maps are going to be just fine, but this was an overview of displacement for you. Hey, remember to hit that like button if you're still here. Thank you so much. Okay, so we've just created a basic PBR texture. Let's say this texture was either too big or too small for what we wanted. We can go back to our mapping node and adjust the scale. We generally want to adjust the scale uniformly across all axes. It'd be annoying to have to adjust all 3 of these values, so we can do one of 2 things. Under scale, either click the top value and drag down. This will allow you to type in a number on the top and have it applied to all 3 numbers. Or what I prefer to do is Shift A and add a value node. Plug it into the scale of the input. And now you can slide the value of this up and down or type in a value. The larger the scale, the smaller the texture gets, and it will eventually start to repeat. Smaller scale will make the texture bigger on the object. But understand that we may have this texture applied to multiple objects, and making it bigger or smaller right here will change the settings on every object that is using this material. So an alternative, and probably the way you should do it, is to go into the UV editor and adjust the scale of the object's UV instead. This on the left is our UV for what we have selected. In this case, it's the entire object's mesh. We can press A to make sure everything is selected, then press S to scale the UV instead of the actual material. This will only affect the scale of the material on this object, and actually even only on the portion of the object you have selected. Pressing G will allow you to move it around if you want to line it up how you want. And R will let you rotate the UV, again, not affecting the actual material itself. That was a ton of work just to set up one PBR, and it was a lot to remember. Well, it's important that you got a basic understanding of PBR material setups, but you don't need to do this every single time you set up a new material in Blender. Let's remove this material and start from scratch with a new principled shader. This is only going to work with Node Wrangler activated in the preferences, which we discussed in part 1, but as a reminder, make sure you go into your preferences, add-ons, and check on the box next to Node Wrangler. Select the principled BSDF shader by clicking on it. Press Ctrl-Shift-T and this file navigator opens. Navigate to the folder where your PBR texture files are. Select the maps that you want to add. I'll choose color, gloss, reflection, normal, and displacement. Press Principled Texture Setup. Amazing. Blender just added all of these maps into the shader editor and connected them exactly as I already showed you how to before. It even organized the textures into frames and added a reroute node. It inverted the gloss and added the normal map. It changed the appropriate image textures to non-color for us. Super easy, and that's really how you add PBR materials in Blender. And as I promised, here are a few extra tips as a reward for making it this far in the video. Once you have your PBR texture set up, there are a few common but optional things you can do. For some of these black and white nodes, like roughness and specular, you can feed them through a color ramp node. This will give you some control over how reflective the material is by either sliding the control points or darkening the white values. You could put them through separate color ramp nodes or through a single node to control both of them together. When you have color information traveling from one node to another, there are a few nodes that you can actually use to adjust the colors. Let's first start with a hue saturation node and plug it in here. Changing the hue could give you a stylized look to the material. The saturation setting can add saturation to the base color or lower it to have a more black and white look. And with the value slider, you can lower the value to make the material darker or increase it to make it lighter. With any node selected, you can press M on your keyboard to mute the node. This removes all of that node's calculations without having to remove the node itself. It's a good way to quickly see if you prefer the material with or without the changes made by this node. Another node you can add here is an RGB curves node. You may or may not be familiar with using curves for color correction, but in short, there's a red, green, and blue channel, as well as a combined channel that controls all of them at once. There's an entire science behind using curves to adjust colors if you wanted to look into that. These reroute nodes are handy when you have one output going to multiple inputs. You can add one by pressing Shift-A and searching for reroute. Or if your nodes are already connected and you have Node Wrangler turned on, you can hold down Shift, click and drag across the multiple connections, and Blender will add a reroute node for you. If you want to move the reroute node, you need to select it and press G to move it around like you would with an object. If you want these nodes to take up less space, you can click this expand arrow at the top left of the node to collapse it down to just this. It removes clutter, but you can quickly expand it back out when you need it. When you have a big node like the principled BSDF, but you're not using all of the sockets, you can select the node and go to Node, Toggle Hidden Node Sockets, or you can press Ctrl-H, and it hides the sockets you're not using. These connections, that are also called noodles by the way in Blender, you can control how straight or curvy they are. I think they might actually be straight by default, but I don't remember. Go to Edit, Preferences, Themes, then find Node Editor and expand this part. Go all the way down to the bottom and there's a setting called Noodle Curving. I have it set to 4. Changing it to 0 will make the noodles completely straight. Increasing it will change the curviness of the noodle. You can adjust to your own liking. My name is Brandon. Don't forget to hit that like button and subscribe if you haven't already. Thank you so much for watching.